Hello everyone. In the today's class, we are going to learn about algebra. Now, in algebra, which we used to say that a branch of mathematics where will be the dealing of alphabetical numbers and simple numerals with standard binary operations. Now, in class 10, you can see that algebra has 4 chapters: polynomials, pair of linear equations in 2 variables, quadratic equations, and arithmetic progression. These 4 chapters will carry 20 marks in the board examination. But we cannot say that each chapter will carry 5 marks. But altogether, these 4 chapters forms of 20 marks. Now, next is that once we want to start with this algebra, we should have a clear concept about these terms: constant and the variable. Constant means which has definite value, fixed value. Variable means which does not have any fixed value, or we can say for the constant value which does not have any units. Just say for example 2, 3, just like this, etc. Now, variables are, if we'll write it down, that 3, 4, 5 here, in case of variables, these 3, 4, 5, these numbers have a fixed value, but variable does not carry any fixed value. So for that, alphabetical numbers, that means alphabets X, Y, Z, etc., these things will be used as a variable. So simple thing is that constant means having fixed value, variable means does not have any fixed value. Now, what is an algebraic expression? Algebraic expression is expression formed by constant, variables, and with standard binary operations. That you know that standard binary operations are addition, subtraction, multiplication, and division. If you take any example just like this, I want to take x as one of the variable, and I want to add some constant on it, x plus 2. So whatever expression is forming here, that is an algebraic expression. That means whatever you will write, that is an algebraic expression. If I have written xyz, this is also an algebraic expression, x multiplied by y multiplied by z. So anything you'll write it down, that becomes an algebraic expression. So algebraic expression is simple, formed by the constant, variables, and with standard binary operations. Now it comes, what is a polynomial? Polynomial is also an algebraic expression, but there is one condition. For algebraic expression, we don't need to see the power of the variables. Whatever we can write, that is algebraic expression. But here, in case of polynomials, that you can see here, power of the variable or variables must be whole number. The power of the variable or variables must be whole number. It means that if I have written x plus y, first of all, this is an algebraic expression. Second, we can see that in this expression, the variables are x and y. X has power 1, y has power 1. It means that 1 is a whole number, so this belongs to this is a polynomial. Next, if I have written x square minus 3z, so here the x has power 2, z has power 1, so it means that this is also a polynomial. So only the thing is that you need to check the power of the variable. If you'll get the power of the variable is whole number, then it becomes polynomial. One more example, if I have written this x square minus square root 2y, now you might be thinking that square root 2 means 2 to the power half. So we can have x square minus 2 to the power half multiplied by y. So you can see that x has power 2, 2 has power half, y has power 1. You might be thinking that this is not a polynomial, but just look at here. The power of x is 2, that is whole number. Power of y is 1, that is whole number. We don't have to see the power of the constant, only we have to check the power of the variable. If that is a whole number, then we can say that this is a polynomial. In a higher classes, it has a form of a polynomial that will be discussed later. So for now, only you are supposed to understand that a polynomial is an algebraic expression in which the power of the variable is whole number. Now next is that terms. Terms means it is a parts in a polynomial or in an algebraic expression which should be and which are separated by plus or minus sign. It is written here, it is a single mathematical expression separated by plus or minus sign. Just look at here, 2x plus 3y minus 8. First of all, this is an algebraic expression for sure. X has power 1, y has power 1. So 1 is a whole number. This is also a polynomial. Now in this polynomial, the terms are 2x, one of the term is 2x, another is 3y, another is minus 8. We have to see the sign also. So this terms are actually what we used to say, that the terms are actually the parts in polynomial or in algebraic expressions which are separated by plus or minus sign. So a few examples just we want to see here as 2x minus 3y plus 4. If I have written just like this, so the terms here, the terms are 2x and another is minus 3y and another is 4. So after that, there will be slight confusion in case of terms, when we can say that terms are like and when we can say that the terms are unlike. Simple thing is that for like terms, just you need to check same variable or variables with same exponents. Exponent or exponents, matlab same variable with same power. Then we can say that like terms, just like this 2x, 3x, 4x. These all are the like terms because you can see that the variable is x and the power of x is 1. So these all are like terms. Next is that unlike terms. Two cases may be there. Number one, different variable or variables, or same variable or variables with different exponent or exponents. Then we can say that unlike terms. Just look at here, in these three cases you can see that there is variable x, there is variable y. So variables are different, so these two are unlike terms. It does not carry any variable, this is a constant value. That's why all these three are unlike terms. Just for the like terms, you need to check same variable should be there and their power should be the same. Then only we can say that like terms. Otherwise, these kind of things we used to say that unlike terms. And you know that terms are separated by plus or minus sign. Types of the polynomial with respect to number of terms. You already have seen this. Monomial, which carries only one terms. Binomial, which has only two terms. Just look at here, some examples are written here. 3 terms. Trinomial, if there are 4 terms. Quadrinomial, if there are 5 terms and more than 5 terms, then we can say that the polynomial having 5 terms, polynomial having 6 terms, just like this. These are a few examples related to this monomial, binomial, trinomial, quadrinomial. Next important thing is that degree of a polynomial. This one is important. Now to understand the degree, just look at here. Degree means highest power of the variable. So here also you can see that the power of the variable. The power of the variable. If the power of the variable is whole number, then it becomes polynomial, and whatever will be the highest power, then that highest power we used to say the degree. Now look at here, in this case algebraic expression, power 2, the power of x is 2, power of x is 1. So okay, greatest, highest is 2. So for this, degree is equals to 2. Degree of this polynomial is 2. For this also, degree, you might be looking into it, the power, highest power, you just see here the highest power is 3, but here the highest power of the variable, we here we can see here 2 as a constant. We are not considering the power of 2. We need to consider the power of only variable. Here the variables are x. The power of x is here 2 and here is 1. So it means that the highest is 2. For this also degree is 2. You can say directly, you can say that it's degree. Third one, degree is 1. And lastly, there is 8 only. What may be the degree of this? So to understand this, first of all, we will see one simple result. We should say that we will see the simple result. Just look at here. If I have written x to the power m divided by x to the power m, is it equals to 1? Yes, it is equal to 1, but in one condition, that this x should not be equals to 0. If this can be written as by using the laws of indices, we can say that if in case of division, power can be subtracted, m minus m, it is equals to 1. We can say that if a to the power m is divided by a to the power n, that can be written as a to the power m minus n. From there we can get this idea. So x to the power 0 is 1. So what can we say that in the previous case we have to find it out the degree of 8. It does not carry any variable. But if there is no variable, means we will be confused that what will be the power of that variable. So just we want to consider some variable with 8. 8 can be written as 8 multiplied with 1. So can't we write that 1 as x to the power 0? Because x to the power 0 is 1, provided that x should not be 0 or infinity. So now look at here, this can be written as 8x to the power 0. The variable is x, the power is 0. That's why 8, degree of 8 is 0. Clear? So whenever you will see a constant number, that constant number will have a degree of polynomial 0. Now next thing is that types of the polynomial with respect to degree. Initially we have seen in the previous slide that types of the polynomials with respect to number of the terms. Here types of the polynomials with respect to degree. Look at here first, degree 0, constant. Just look at your example 8, 10, 6, etc. In the previous slide also just we have observed, we proved that any number which has power 0 is 1 except 0 and infinity. So if degree is 1, linear equations. For this in detail we have another chapter in algebra. Algebra second chapter, pair of linear equations in two variables. Quadratic, that is also there in our syllabus in class 10. That is third chapter from the algebra section. So quadratic polynomial means degree 2. If there is degree 3, cubic, just look at your examples. Degree 4, biquadratic. If there is degree 5 and more than 5, then we can say simply a polynomial with degree 5, polynomial with degree 6 and all. So these are few examples and important types of the polynomial. So the types of the polynomials are divided in two sections. One of the part is according with the number of the terms, and this one is with respect to their degrees. So sometimes in examination the question may ask you that what is the degree of constant polynomial. So there the options may be provided for you in MCQ. Definitely in MCQ the options will be provided for you. There the options may be 0, 1, 2, 3, 4. The correct option is 0. Now next important thing that we are dealing in this chapter, polynomials of class 10, coefficient. It is a numerical factor of a term of a polynomial. Now how to understand this? If I am writing here 2x minus 3y minus 5z, just like this, 5z. So look at here, coefficient of x is, which constant number is multiplied with x? 2. So 2 is the coefficient of x. Coefficient of y, you can see here, which constant number is multiplied with y? That is not only 3, this is minus 3, you have to see the sign also. Similarly coefficient of z, that is equals to minus 5. So just look at here, numerical factor of a variable in a term. In any term, whichever will be the constant factor or numerical factor of that term, we used to say that is coefficient. Sometimes you may get that this is for a broader section. If you have a multiplied by b multiplied with c, so if you want to find it out the coefficient of a, accept a which number is multiplied with a, bc will be the coefficient of a. Similarly for b, ac will be the coefficient. For c, ab will be the coefficient. With this concept also we can understand this term constant. But to find the constant, it is a numerical factor. Here in class 10, numerical factor of a variable, but don't forget to check their sign also. Sign you need to check. If it is plus, no problem, but if it is minus, then you have to write it down minus also. Now next important thing that we can find it out in the chapter polynomials, that is zeros of the polynomial or roots of the polynomial. So first of all, just I want to write one polynomial to understand this x minus 2 by looking into the name zeros of the polynomial. What may be the meaning of the zeros of the polynomial? This is very much important. Most of the learners will find it very difficult to understand the concept of the zeros. For you, actually, especially the zeros of the polynomial. That's simple example. Just think of any number which makes this polynomial 0. But look at here, in this case, we cannot change the value of 2. 2 is fixed, that is constant, but here variable is x. Just try to find it out the value of x which makes this polynomial is 0. Let me try once. When x is equals to 0, so p of 0, so this x should be replaced with 0. So 0 minus 2, it gives us minus 2. So we are not going to get the 0. Similarly, if you'll check for p of 1, if you'll put x is equals to 1, if you put x is equals to 1, so you can see that p of 1 is 1 minus 2. 1 minus 2 is minus 1. Still we are not getting the value of the polynomial as 0. But here let's see, when x is equals to 2, we try to find it out p of 2 with this polynomial. So this x will be replaced with 2. 2 minus 2, it gives us 0. So in a simple way, that x is equals to 2 is a 0 of polynomial px. So if you need the definition is whichever value or values of the variable which makes the polynomial 0. Killer of the polynomial, we should say that. The ultimate value of the polynomial becomes 0, then that's why it is said as a zeros of the polynomial. So this is the concept for this zeros or roots of the polynomial. Now next is that this is a simple definition for this value or values of the variable or variables which makes the polynomial 0. Now every time, whether we need to do the trial and error method, or do we have any concerned particular traditional, or any particular method to find it out the zeros of the polynomial? For that, if one of the polynomial that is given to us, x minus x plus, let it down, let it be x plus 7. So ultimately, what should be there? This polynomial should be equals to 0. Let px is equals to 0. At the end, the value should end to 0. Now this px will be replaced with x plus 7 is equals to 0. It gives us that x is equals to minus 7. So clearly we can find it out that the value of x is minus 7. Now to check whether x is equals to minus 7 is a 0 or not, just put it there. P of minus 7 gives us, just in place of x, write it down minus 7, and plus 7 is already there. This gives us 0. Okay, then we can say that this is the zeros of the polynomial, this px. Now whatever the examples that we have seen just now all are linear polynomials. Now next we are going to find it out the zeros in case of the quadratic polynomial also. But remember that the quadratic polynomial, that is from the syllabus of CBSE Class 10. I want to write one example here, which is x square minus 4. Now look at here, in this polynomial, in the variable x, the degree is 2. We just want to find it out the value or values of the variable or variables. So here the variable is x. We are finding the value of x, which makes this whole polynomial 0. First of all, for sure, when x is equals to 2, p of 2 will be 2 square minus 4. 2 square is 4 minus 4, it gives us 0. Okay, so that is clear that x is equals to 2 is one of the root. Now next is that degree is 2. Can't we get another root also? Can't we have another number which makes this polynomial 0? For that, let's check for negative of this 2, that is minus 2. So when you'll take that x as a minus 2, p of minus 2 will become minus 2 whole square minus 4. But remember that negative to the power even number is always positive 1, and negative of 1 to the power odd number is always minus 1. Don't forget this. So here the power is 2, so the sign will become plus. The square of 2 becomes 4. 4 minus 4, it gives us 0. So here we can see that for this polynomial, quadratic polynomial, it has two zeros. It means that in this polynomial we have two values of the variable, which makes this whole polynomial's value as 0. So slightly we can guess that in a previous examples we have seen for the linear equations, there we found that only 1 0. But here in a quadratic equation, quadratic polynomial, we are getting two zeros. So somewhat we can say that the degree is matching with the number of zeros. In a linear polynomial, degree is 1 with the one variable, number of zeros 1. Here in this quadratic, in the case of quadratic, degree 2, number of the roots are also 2. So let's take another example also to verify that a quadratic polynomial has exactly two roots or not, or what are the conditions there to check the number of the roots, to find the number of the roots. So in the previous case also we have seen that x square minus 4. Just I want to write here one polynomial, px is equals to x square minus okay 3x plus 2, one of the easiest polynomial. You can see that this is a quadratic polynomial. We need to find it out its root zeros. For that we will assume first that let p of x is equals to 0, and we can write it on that, which implies x square minus 3x plus 2 is equals to 0. Now to solve this, one thing should be there, that for this we need to go with the factorization, then only we will be able to find it out the roots of this quadratic polynomial. For that factorization we will use a middle term splitting. To use the middle term splitting, it is very easy, just look at here. So middle term is 3x because the power of x is 1. Either you have to write the power of the variable in decreasing order or in increasing order, which will be the middle term, which will be the term in the middle that will be considered as a middle term. That is one of the rule. Now there is a constant 3, that 3 is going to split into two parts with respect to the coefficient that we have in the first term and the constant at the end. So you can see that what is the number that we have in the first, that is 1, and what is there at the end, that is 2. 1 2 is 2. So 2. Now which sign that we need to put here? For that confusion, the sign in the first term, that is plus, and at the end there is plus, so plus into plus gives us plus. So we can write 3 as 2 plus 1. Hope it is clear to you all. Now next is that x square minus 2 into x is 2x, minus into plus minus x plus 2 is equals to 0. Now remember that every time whenever you will multiply, it comes under the multiplication. Just follow that SCV rule. S stands for, first of all you multiply sign, second C stands for constant, you have to multiply the constant or coefficient, and V means variable. At the end only you are supposed to multiply the variables. Here I did the same. So there are four terms, so middle term is already split it, just find it out the number of the roots. So if we take x as a common, here will be x minus 2, and from this 2 we don't have any common, but if there is no common means 1 is always there as a common, 1 as a universal common, so we'll take minus 1 outside. But remember that whenever you will take minus as common, every time the terms will have a changed sign. So x has minus sign, now it becomes plus. Now 2 has a plus sign, it becomes minus. And surprisingly, you can see that in these two terms, we have one part that is as common. So that is x minus 2. We will write for once, and the remaining in the another bracket gives us 0. Now this has broken into two parts as a factors, x minus 2 and x minus 1. It means that if you divide this polynomial with x minus 2, it will divide completely. Even with x minus 1 also, this polynomial will be completely divisible. So once we reach here, we are supposed to find it out the roots. Look at here, if the product of any two numbers are 0, if the product of any two numbers are 0, so the condition is that either a is equals to 0 or b is equals to 0 or a, b both are 0. If the product of any two numbers are 0, then in case of numbers, if the product of any two numbers as 0, then one of the number should be 0 or both should be 0. So here also you can see that the two things, their product as 0. So here we can write either x minus 2 is equals to 0 or x minus 1 is equals to 0. So here you can say that x is equals to 2, and from here x is equals to 1. So these x is equals to 2 and 1 are the roots of this polynomial or zeros of the polynomial. That is, x is equals to 1 and 2 are the zeros of given polynomial px. Now in the previous example also we have seen that this is quadratic polynomial having two zeros. One of the zero is 2 and another is minus 2. Here also in this quadratic polynomial we find it out that the roots are 2, number of roots are 2. That means we can say that if root exists, and what is the condition for the existence we will see later in the chapter of quadratic equation. So here, if root exists, in case of quadratic polynomial, there will be exactly two roots. Now I just have told you that if root exists, that means if real root exists. That should be clear to you. That should be clear to you that every quadratic equation will have two roots. But here, under what condition we can get the real roots, that we will discuss in the later. Now in this class, we have seen what is an algebra and what are the chapters that we have in a CBSE class 10 from the section of algebra. Then after we entered with the constant and the variables, we have learned about the zeros of the polynomial and what is constant, what is variable, what are the coefficients according with the degree, what are their types, and according with the number of the terms, what are their names, that we already have seen here. And at the end we just find it out that if there is a linear polynomial with a single variable, then you remember that there is only one root. But in a quadratic case, if there is, that quadratic means degree 2, that means it has maximum 2 roots. But whether the roots exist, real root exist or not, that we will see in the next class. Keep learning. Thank you very much.